Hello everybody. In this video we are going to be discussing polynomial functions, and specifically their zeros and multiplicity. All of this stuff is in section 2.2 of your textbook if you would like to follow along. All right, so to start off with, we just wanted to review with you the real number system and what some of these things look like. We're not going to go through this whole thing in detail, but we are going to hit some highlights. We want to start off by talking about real numbers. Real numbers are any number on the number line. Okay, so if this thing has a home, if you have a particular value that has a home on the number line, it is a member of the real number system, okay? Now, even if you're approximating, so for instance, pi is a tough one, right? Pi lives over here with irrational numbers. You don't need to know that one specifically. I'm just using that as an example, though. It's 3.14 and on and on and on and on, right? It goes on forever with no repeating patterns, so that's what makes it irrational. But we can approximate that and find a home for it on the number line. So that means it is in fact a real number, even though it's that wacky decimal that keeps going for forever and ever. Now, rational numbers are like the biggest category, other than there's the rational numbers and the irrational numbers. So rational numbers has a bunch of subsets within it, okay? If a number is irrational, it's just irrational. And the irrational numbers, let's hit that since I'm talking about it, would be pi or something like the square root of 2 or the square root of 5 or something like that that cannot be simplified all the way, okay? So those would all be examples of irrational numbers. They're going to be repeating, non-repeating, non-ending decimals, okay? So decimals that go on forever with no recognizable repeating pattern. Now, rational numbers are going to be numbers, basically all the other numbers in the real number system. So rational numbers can be expressed as fractions. And they contain everything else, all right? So 1/3, 0.5, right? So 0.5 is a decimal, I know, but it can be expressed as a fraction. It can be expressed as 1/2. So that's the reason we would consider 0.5 a rational number. It can also be all of the other numbers that are going to be contained in these boxes, okay? So typically what we do is we think about rational values as being fractions. It's not just fractions, it's all of those numbers, but a lot of times when you hear rational numbers, you can figure that fractions are coming along, okay? Integers, of course, are all of the positives and the negatives, no decimals, no fractions, okay? So it's going to go to all the way to negative infinity, so dot, 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 -3, -2, -1, 0, 1, 2, 3, and on forever to positive infinity as well. Okay, so all the positives and negatives along with 0, because 0 is neither positive or negative, and it goes forever in both directions, no decimals, no fractions, okay? And for the purposes of this video, we're not going to go into the whole numbers and the rational numbers, okay? So there's your quick reminder of what the real numbers are, and then how they're broken down into rational and irrational numbers.